Hello everybody, in this lesson I will introduce the Theorem of Pythagoras to you. Pythagoras was a Greek mathematician and philosopher who lived around 500 years BC. Although more than 2,500 years have passed since then, his theorem remains a very powerful tool in mathematics. Now, important, it has to be a right-angled triangle in order for you to use the theorem of Pythagoras. And now what does the theorem say? It says the hypotenuse squared. Wait, let's just quickly have a look at this one. Where do we find the hypotenuse? The hypotenuse is the side that lives across from the right angle, the 90-degree angle. So the theorem says the hypotenuse squared is equal to one side squared plus the other side squared. And this is always where we will start when we deal with the theorem of Pythagoras. And then in order for our little sketch, we can say it is c squared is equal to a squared, the one side, plus b squared, the other side. So it really doesn't matter if you say a squared first plus b squared or the other way around, as long as it's one side squared plus the other side squared. And then I also want you to, whenever you use his theorem, you have to add the Pythag next to it so that every mathematician knows that you used the theorem of Pythagoras. Now in this slide I will teach you how to write down the theorem of Pythagoras for different triangles. So it says, for the following triangles, write down the theorem of Pythagoras. Now, first of all, I want to teach you something. Did you know that if you look at the first triangle here, you can also label this little side, ML, as little k. So you say if this is the big angle K up there, then the side, let me do it like this, the side that lives opposite that angle is called little k. The side that lives opposite the big angle M, we call it little m, and the side that lives across from or opposite big angle L is called little l. And remember, this side M is also the hypotenuse because it lives opposite the right angle. Now, in order for triangle KML to write down the theorem of Pythagoras, we will say always hypotenuse squared is equal to one side squared plus the other side squared, and we add Pythag. And then in terms of the sides, we can say hypotenuse is m squared equals one side is k squared plus other side is l squared. Then for the next triangle PSR, the theorem of Pythagoras, first of all, do you agree that we can say that this side, the hypotenuse, is little s? This side opposite from big angle P is little p, and this side opposite big angle R is little r. So the theorem of Pythagoras, we can write it as always hypotenuse squared is equal to one side squared plus the other side squared, and we add Pythag. And then in terms of this triangle, we will say little s squared, the hypotenuse, is equal to r squared plus b squared. Now, before we start with the actual sums, I just want to show you there's something we call Pythagorean triplets. So in a right angle triangle, you get, if this side is 3, this side's length is 4, then the hypotenuse length is 5. So 3, 4, 5, you call that a Pythagorean triplet. There's more. If this side's length is 5, this one is 12, and the hypotenuse will be 13. So 5, 12, 3 13, is a Pythagorean triplet. And another one, 8, 15, and 17. Example 2. Calculate the length of the unknown side. In other words, we want the length of FE. Now first, I suggest that you label this side opposite the big angle D, little d, the side opposite big angle E, little e, and the side opposite big angle F, little f. That will just help you. Then we can say we always start with hypotenuse equals one side squared plus the other side squared. And you have to add the Pythagoras. Then the hypotenuse is the side that's opposite the right angle. In other words, I can show you here. There's your right angle. Therefore, d, little d squared is equal to, and then one side is f squared plus e squared. And it doesn't matter in which order you write that. Then we can substitute. D squared is what we're looking for. F is 4 squared plus e squared. E is 3. Then 4 squared. Remember, 4 squared means 4 times 4, not 4 times 2. And that one is 16. And then there's d squared. 3 squared is 3 squared means 3 times 3, which is 9. Then d squared equals 16. I'm here now, sorry. 16 plus 9 is 25. And then when you want to get rid of the square, what you will do is you will take the square root both sides, and then you end with only d. D is equal to 5. Example 3. Calculate the length of the third side in triangle KLM. Therefore, we are looking for KM. Again, it is the hypotenuse. Now this one, I didn't add in little l, little k, little m, because I want to show you that you can still use the length of the sides as it was given. So again, the theorem of Pythagoras, you always start with hypotenuse squared is equal to one side squared plus the other side squared. So in terms of triangle KLM, we can then say that the hypotenuse is km squared equals kl squared plus lm squared. And remember, you have to add Pythag. There. Now let's see. Km squared, that's what we're looking for, equals KL is 5 when we substitute, plus LM is 12 when we substitute. So therefore, 5 squared means 5 times 5, which is 25. And 12 squared means, let me do it here, 12 squared means 12 times 12, which is 144. And then we can add 25 plus 144 is 169. And then to get rid of the square, because we only want km, we will take the square root both sides. And then the square root of 169 is 13. And then I also want to show you this. Can you see that there were no units given? So therefore we can write there 13 units. Thank you for watching my video. If you click on the video in the left-hand corner, it will take you to the next lesson, and there we will do more examples on the Theorem of Pythagoras.